Yeah, so yesterday, like we have seen about the migration using Aura to PG. So we have migrated structure as well as data on both um, so using Aura to PG tool, right? So and we have verified objects as well. So after the replication and to order in order to have a fast cutover, we should have a golden gate replication for fast, the continuous data replication from Oracle to Postgres, right? So when you think about the golden gate, it is licensed, as we know. If your company is already having a license, you can go with golden gate for when you are doing the migration part from Oracle to Postgres. So the thing is, since it is a heterogeneous replication using golden gate, so we have some drawbacks. Like drawbacks in the sense like we cannot replicate the uh, DDL operations with the golden gate in the heterogeneous environment. Okay, and also we cannot start the integrated. Maybe we can start integrated, but not sure. As per my knowledge, I think we cannot use the integrated golden gate type. So we can only go with the classic, which is the old one. Okay, so while we start the extract and pump. So we know that we have a schema bank underscore schema, right? Here also we have migrated to the same schema, so bank underscore schema. Now what we can do, we already have a set of tables and we already have migrated using Aura to PG and we already have the data. So from yesterday, whatever we have migrated, from there we are going to resume now. Okay, with using Golden Gate, we are going to replicate the data. So here we have to install the Oracle Golden Gate for Oracle database, and for Postgres we have to go with Postgres Golden Gate. Okay, so since my Oracle database is 19C, I have installed 19C Golden Gate as well, GG binaries. But for Postgres, I don't see 19C binaries is available, Golden Gate 19C. So first initially I tried with 12C Golden Gate, but it has some for Postgres, it has some bugs, okay, regarding the PG catalog tables. It cannot able to read the tables, okay. Golden Gate is not able to read some of the tables. So because of that, I have went 19 is not available. I have 21C, okay. So I have installed 21C GG for the Postgres, okay. So now what I'm going to do, I'm going to create an extract here to capture all the changes from the tables, and I'm going to start the pump. Okay, so extract, what it will do, it will capture all the changes. In the extract, we have to mention which schema we need to add as a part of replication in the Golden Gate parameter file, right? So here in this extract, I'm going to mention the bank underscore schema, and it will generate the trail files, right? So these trail files will be in the local system, or you can directly push to remote machine. If without pump, also fine. So here I'm going to configure uh, extract and pump. Okay, so extract will push the trail files into local file system. Okay, and pump will take those trail files and it will push to the remote machine. Okay, so here I'm going to configure the replicate. Okay, so the replicate will apply those changes. What are the trail files the pump pushed, right? So it will apply the changes to the scheme. Now, only thing is, it is like similar how we configure from Oracle to Oracle, but when you come to heterogeneous migration, you have to create something called def file. Okay, so this def file is very important because the def file, whenever you have any different data types, okay, a different structure, so this def file will work because the data types, whatever you have in Oracle table may not be same in the Postgres, right? If it is a number, it may be something double precision or integer, whatever it may be. So def file, if you create the replicate will understand, okay, even if you have different data files, the data will be replicated. It will take care of even if you have different data types as well. So that is the reason def file is very important. We have to create the def file from Oracle side, and we have to copy the same def file into the Postgres. Okay. Now here in Postgres, Oracle, we know, right, how to install Golden Gate. It's very lightweight software. You can directly install with the Oracle Universal Installer or maybe silent method, right? So just you need to mention like for which Oracle binaries you want to install Oracle Golden Gate, and you want to mention the manager port. That's it. In Postgres, even you don't need to install any Golden Gate binaries. You have to download from Oracle eDelivery, and you can directly unzip this or Postgres Golden Gate binaries. That's it. You don't need to even install. You need to just unzip. So after you unzip, you will get all the binaries, and you have to create all the subdirectories, right? So create subdirectories. If you do, it will create all the subdirectories like dir, dat, dir, prm, dir, temp, dir, def. You have so many folders, right? So it will create all those things. Okay. Now let's come to the practical part. So I have this is my Oracle machine, DB server 01, and this is my Postgres, right? So now I have
one question. We need to start the extract before we do Vara to PG, right?
Yeah, usually we need to start before we start the data migration only. But the thing is, maybe in real time to do a database, migration, it may take some lot of time, right? So in that meantime, see, yesterday we have very small tables and very uh, less data, okay? But in real time, okay, you have very huge data. So what you have to do, you have to do two times. First for POC, anyhow, you will be doing the migration, right? So while you do the actual migration, that time first you start the extract and pump. Okay, then you can do the data migration with Ora to PG. Okay, and you can start this data migration using SCN, which I have shown you yesterday on option with Ora to PG, right? So with that SCN, you can start the replicate. So yeah, that is the way that we'll do. Okay. Yeah. So now here I have GG underscore home. Okay. So I have already downloaded the Golden Gate software. Okay. If you go inside, this is the binary, right? So if you just unzip this, you will be having this folder. Okay. Inside the disk one, you have /uninstall. You can directly just go and install. It's straightforward. So once you install, I have choose the Golden Gate home is this one. So this is my Golden Gate home. Okay. And here you have, so you have all the directories, right? So you know that, so from in the DRPRM, you have parameter files. Okay. And DRDAT, you have the trail files, right? So you have def files, you have temp files, you have report file and discord file here. Okay. You have checkpoint file. So all the directories you will have when you install, right? So currently I have only manager is running. Okay. So in the manager, I have only parameter port. So port with 7809, which is a default port. Currently my manager is running. Okay. In the source side. Now in the target side, I have installed the binaries. It's not installing, it's directly just unzip. That's it. So you don't need even. So this is the software, okay, which I have downloaded. I have just unzip it. When you unzip, it will generate a tar file. So this tar file, you can just untar it. So you will get all the binaries, okay? But you don't get these directories. You have to just connect to GGSCI and you have to, okay, let me export the path. You have to just create subdirectories. That's it. So it will create all the necessary directories to you. So this is my GG home. Okay, let me export. Okay, so I have exported the Oracle binaries. That is the reason. So let me export the. Okay, so here I have managers again. So view param MGR. So here the port is running with 7809, which is its default. So you have to just create subdirectories so that it will create all your necessary subdirectories. Okay, at the port side. And one more important thing is you have a file called, you have to create one file called odbc.ini file. This we'll discuss. Okay. First, let's come to the source side and we can just create the extract and pump here. Okay. So for that, I have already created the parameter file. So we'll show you how the parameter file looks like. So before that, we can also have the credential store. Okay. So I have already created the credential store. The credential store is just order credential store, add user, okay, and the username with the alias name. This is just to log in without any password. I'm just going to create a credential store to log into the database. Okay, so the credential store, the name which I have given is bank underscore schema, the alias name. So I'm going to connect to this uh, database using the credential store, right? So I have successfully logged into the database, right? So with the help of this credential store. So I will provide the document how we can create a credential store. It's very straightforward. Just with alter credential store, credential add user and username at the rate the TNS name of the alias name. So that's it. It will just create the credential store. So I've connected to the the database using this credential store. Okay. Now, so once you log in, so here if you see, we have connected to the bank underscore schema. Okay, so if you just do list tables, what is our schema? Bank underscore schema dot star. So it will list all the tables, whatever we have under this user. Okay, so these are the tables which we are going to migrate, right? So, sorry, the replication. So these tables we are going to add in the replication. So these tables we are going to migrate to the Postgres. Now, um, so let's create the extract and pump. So before you create the extract and pump, here we have seen we are able to log into the database and we are able to see the tables, right? So the list of tables, right? Now we can also verify. Um, there is another utility. Let me open the Oracle documentation. 1 minute. So capture table depth. Okay, so you have something like this. Okay, so this parameter will just to check whether it will check the table definition. It will just capture. So we can just check this tables. For example, for accounts. Okay, so this is the definition of the account tables. So in similar way, we can also log into the database of Postgres and we can list the tables and it has to capture. So in 12c, this is the problem. So it can able to list the tables, but it cannot able to capture this table definition. Actually, internally it uses the dictionary tables to capture this definition. Okay, but in Postgres you have some bugs, which the Oracle documentation also they have provided. They have some bugs in version 12 Golden Gate. It cannot able to capture. If it is not able to capturing, then your replication will not able to apply those changes to these tables. This is one drawback. So since it is a 21 version in Postgres, it is okay. Okay, now in the source side, we have created a credential store and we are able to log in with the credential store to the database to this user bank underscore schema in Oracle. And we could able to list the tables and we can capture the definition as well, right? Now we can do the same thing in Postgres side. So in Postgres side, if you want to log into the database as similarly like with the DB login, you have to create a file called odbc.ini file. This is very important in Postgres. So what is this odbc.ini file? In this odbc.ini file, you will mention the driver details because with the help of drivers only, it will able to connect to the uh, Postgres database, right? So for this purpose, we have to create ODBC data sources. Okay. So here installation directory. So this is my binaries of my Postgres, and this is the name of your driver. Okay, this name can be anything. I'm just mentioned like gg underscore Postgres. You have to use this driver only in the parameter file of replicate, and even when you log into the data, I mean, in the gg, when you log into the database, you have to use this driver name only. Okay. And this is the default driver name. This is the default driver name in up to version 21. After 23 AI, the driver name they have changed. Okay, until up to that time, this is the driver name. The drivers will be present by default in as a part of your Golden Gate binaries. So if you go inside lib folder, you got able to see this driver. Okay, this is the one. When you install 23 AI database, you will get some other name. Okay, until 23, this is a common driver name. Okay, which we have to use for Golden Gate purpose. Okay, this is important. So on which database you are going to replicate? Okay, so for example, I think our database is okay. So we are our database is Sky, right? Yesterday, which we have created, not test. So in this database, this is I'm going to log in with the Postgres user. Okay, so I'm going to save this. If you connect to the SQL Plus, if you see /l, so we have migrated to this database yesterday, right? So /dm set such underscore path equal to /dt. Okay, so if you verify the data, you should have the data because yesterday we have migrated, right? So we have data here, accounts, right? So yesterday we have migrated. So we are going to give these database details, okay, in the odbc.ini file. So in the odbc.ini file, so what we have mentioned, the Golden Gate binaries installation and the driver name and the driver location. These are very important, okay? These three lines are very important. And this is important, the connection details, okay? So with the help of these drivers only, we are going to connect to the Postgres database in the Golden Gate. Okay, for this purpose, we have to create this. So for this purpose, what I'm going to do, I'm going to export the ODBA location as this. Okay, this is my ODBA file. So with the help of ODBA ini variable, we have to export this location. Okay, now with the help of this driver name, I can able to connect to the database with the help of DB login. So what I will do, DB login source DB, and this is my driver name. Okay, and then I'm going to connect with the user ID, which is my Postgres, right? Postgres. So now if you see, it has connected successfully to the database with the driver name, right? So here, whatever the driver which we have used in the ODBA file, with the help of this only, we have to log into the database. Now, if you see a list tables, so from the Sky database, our schema name is same, bank underscore schema, right? Dot star. So we are able to list all the tables, right? Here you could see some extra tables because you have the partition tables. It will treat the partition tables as a separate table. So here you will get the match is 14, but in Oracle side you will get 11, right? 11. Okay, because extra 4 tables you have partition tables. So that is the reason it will show this matching. Now you can also do the capture of the table definition. And you should also be very careful with the case sensitive, because in Postgres by default, even though if you give caps, it will take the lower cases. So you should be careful with the cases as well. Okay, so if you keep in the double quotes, whatever it may be, it will capture. So I'm able to capture this table definition as well in Postgres side as well. Okay. Now we have verified both side, Oracle side and Postgres side, about the connectivity. I'm able to log in with the credential store or with the username or password in in Oracle, and I can able to list all the tables in the schema, and I can able to capture the definition. Similarly, in the Postgres side also, I can able to log in and capture these definitions, okay, with the help of drivers especially. So you can use this driver name to connect to the Postgres, and then you can capture the list of tables and the definitions. Now we can configure the extract, okay, at the Oracle side. So this is my Oracle database. So here I'm going to configure my extract. So for this purpose, my extract name is EPOS. Okay. So let's see view param. I have already created the parameter file. Okay, looks like it is not there. Okay, let me create it. Edit param. So here I'm going to create my parameter file. Okay, for this I'm going to mention what is my extract name. This is how my parameter looks like. So extract name. Sorry, not this is the one. 1 minute. So this is my extract name, and I'm going to connect as a with bank user. Okay, and this is my trail file. So the trail file location is this is the old location. So let me update the new location. Okay, so this is my okay. Sorry, so this is the correct one. Oracle binaries is this one. So in Oracle binaries, the my trail file name will start with EP only. Okay, and I'm going to capture all the tables in the bank underscore schema. So this is how my parameter file looks like. So bank underscore schema dot star, which means it will capture all the tables. If you want a specific tables to be part of replication, you can just mention some table name here instead of star, because I want to capture all the tables. So this is the extract file looks like. So extract name, and I'm going to log in with the alias name to this bank underscore schema because I already created the alias name using credential stored. I can able to log in without any password. Now this is the local trail file. Okay, so your extractor will capture the changes of these tables and it will generate the trail file with the name EP000001 and so on, something like this it will capture. So this is the parameter file looks like, my extract parameter file. Now I'm going to add the extract. So either you can create the something like this. So add extract name, begin now, and I'm going to add the trail file as well. Okay, so something like this. So now I'm going to start my extract. Okay, looks like it's got abandoned. We'll see why it abandoned. So right, if any coordinate process is getting abandoned, we are going to check the report file, right? What it is saying, source compatible version is 19. Okay. Okay, something this is not properly added. So let's see exactly what I'm going to delete this extract. Okay, so view param. Maybe while adding, I have added the wrong. Okay, let me take because okay, now I'm going to add the proper extract path. Previously, I have added some different home one, so that is the reason we have that issue. Okay, so previously I have added this is the wrong trail file location. If you see here, this is the wrong home actually. So now I have updated to the correct home, because in the parameter file we have, this is the GG home, right? So I have updated this GG home, and now let's start this extract. So it has started, and we'll see, because your SCN number should be updated here. Okay, let's wait until the SCN number updates. RBA is moving, which means running properly. Okay, now it has, you see the SCN number has been generated. Okay, so if you want more information, you can just see detail. Okay, here it will show all the files, report files, parameter file, checkpoint file, and error log file. Everything it will show here. And you can also see, okay, a trail file has been created with EP, right, in the dr.dat file. Okay, so your extract has been started. Now we have to push this same trail file with the help of pump to the remote server, which is your Postgres, right? So for this purpose, what I'm going to do, I'm going to create parameter file for the pump. Okay, so let me take this. I will think my pump name is something like this. Edit param POS. Okay, so here I'm going to create my pump parameter file. So pump parameter file looks something like this. Pump name, okay, and remote host. So remote host is, this is my Postgres remote host. If you see, let's take the IP of my Postgres. So which is 1.11. So this is the IP of my Postgres server, and IP of my Postgres manager port also same 7809. And this is the remote trail file. I'm going to tell to copy as a PE. Actually, it has generated EP in the local. You can change the naming convention as well. It's your wish. Whether you want to be the same naming convention in the pumps, I mean in the replicate side, or you can change the trail file names, whatever the naming convention you want. So it will copy the trail file name as PE, okay, in the target. And this is the schema which we are going to tell, right? So I'm going to save this, and I'm going to add the pump now. So for adding the pump, so we can just mention this is the local trail I'm going to add, and we are also telling to the pump to copy to the remote trail. Okay, so info all. So this is the remote trail and this is the local trail. And the sequence number, actually it will generate from 0, right? So all the trail files. So I have just mentioned 0. Okay, now I'm going to start my pump. So we'll wait. Okay, so you could see 0 lag now. You can check in the Postgres side, you receive this trail file, right? In the dr.dat location. So because we have mentioned the same location in the parameter file to push the trail files, right? So if you see yes. So this is my remote trail file path. In the dr.dat, it has generated with PE only. So, but local trail has been generated with EP. You see, it has generated with EP, but it has pushed as PE. So your trail file has been received to the target. So currently your so extract and pump is running properly. Okay, so it is capturing the changes and it is generating the trail files. It is pushing the remote trail files to the target. So now here we have to configure the replicate, right? So for configuring replicate, so you can set the batch profile. Always you don't need to move here and there. Okay. So here I'm going to configure the replicate. So for configuring the replicate, first I will log into the database using driver, right? And one more important thing is here before you before you configure the replicate, as I told, we have to create a def file. Okay, so def file is very important. So you know, right, what is the use of the def file? So def file, if you have different structure, it will help you to replicate, especially when you do the heterogeneous migration. So my def file looks something like this. Let me prepare the def file. Just the path gg home. So with the help of defgen, we are going to create this def file. So edit param defgen. Okay, here I'm going to tell on which name I have to generate. So this is my def file. Okay, so edit param. Okay, we don't need this. Okay, so this is the def file, and here, so my username is bank schema and my password is this, and this is the tables which you are telling to capture. So what it does, it will capture all the structure of the tables and inside this, and it will generate the def file here. Okay, so this is very important. If you're not doing this, it will fail. Your replication will fail. So this is very important to configure. So that is the reason I have created this def file. You know, right, how to generate the def file. So you have a utility called defgen. Okay, inside the word gg binders. With the help of this defgen, you can able to generate the def file. So here in my case, you have to mention the parameter file. So my parameter file is this one. So with the help of defgen, I'm going to generate this parameter file. So what it's telling, it's already exist. Okay, let me go and delete it and generate it again. So this is the def file. Okay, and it has given some warnings because few tables doesn't have any unique key or primary key. It's recommended always to have a primary key for the tables, especially for golden gate or logical replication. This is mandatory, right? So it gives some warnings that you can ignore, but in real time, it should have a primary key or unique key. Okay, this is the my def file looks like. Okay, so what it has, it will capture all the table definitions. If you see, so all the definitions, and it has captured for each column entry. For example, if you see the accounts table, okay, it has captured 5 columns, and it has captured the length, all the definitions. Okay, so this def file will help you for heterogeneous migration, even though not only for Oracle to Postgres. If you migrate from Oracle to MySQL or MySQL to Postgres, this defgen file is very important. So from source side, you can just generate the defgen. You can just create a parameter file, what name you need the defgen, and you can just, by using the defgen utility, you can generate the definition file. So the definition file looks something like this. And the same definition file you can copy to the target Postgres side. Okay, so in Postgres side also you have this location, right? So let's go to this location, defgen. Okay, so our Postgres binaries is different, right? So gg home dir def. You can copy the same file, whatever it has generated in the source, ggtest.def. Okay, and you can just copy this entire content here. The same file I have copied to the, whether you can do with SCP or you can copy with WinSCP or whatever. So I just copy the content and I have pasted to the Postgres side. So all this content I have copied, right? So whatever the def file, what it has generated, everything I have captured and I have copied to the target Postgres side. Okay, so this is very important step because your replicate has to understand this def file and then only it will start replicate. So for heterogeneous migration, this is mandatory or important thing. So I have my def file. Now what I'm going to do, I'm going to create this replicate. Okay. So to do that, actually I have already configured my ODBA file. So with the help of ODBA file, I'm going to log into the database, Postgres database, right? So in this driver, we have already mentioned what target database it has to connect. Okay, Sky database. And if you also see the list tables, we already verified this, but we can just verify one more time before we configure the replicate. So dots dot. So these are all the tables which is already present in your in your database, right? And you can also capture with the help of definition file, capture def file, right? So if you want to capture, you can just capture this as well. Okay, now we are going to configure the replicate. So to configure replicate, I have already parameter file. So the parameter file looks something like this. So replicate name, and here I have mentioned the definition file. This is important, right? So with the help of source defs parameter, you can mention the definition file, and this is the environment details. So default your character set is UTF-8, and here I have mentioned the odbc.ini location as well, and this is the driver name. This is very important. So people will think here target DBs, you have to mention the DB name, but not the DB name. You have to mention the driver name. Anyhow, in the driver, you have already registered the database Sky, right? And with the help of user Postgres, password Postgres, you are going to connect. Okay. And then this is the Discord file, which I have mentioned to generate the Discord file. And this is very important. So from source, from which table to which, so from which schema tables you have to map. So here in the source, I'm going to map from bank underscore schema to target. So my target also same, right? Not public. I have my bank underscore schema only. In the target side, Postgres side also, I have to replicate from this schema to this schema. So this is very important. I have created a parameter file. Now I'm going to add the replicate. So to add the replicate, we have to mention the trail file. The remote trail file where it has generated, that same location we have to add. So add replicate name, and this is the extract file which it is generating with PE. Okay, so you have to properly add it with the same naming conventions whatever it has generated. If you see, even you can check directly here. ls minus LDR stop. So the trail file looks something like this. Okay, that is the reason I have mentioned the trail file. Now I'm going to start my replicate. Start replicate. Okay, since I don't have any changes done, right, from source to target, that is the reason I'm directly starting the replicate. But in real time, you have to do with SCN only. Okay, to be in sync, you have to start with the SCN and the data migration, especially Aura to PG. You have to capture the current SCN from Oracle side, and in Aura to PG parameter file, or in Aura to PG option, we have SCN, right, hyphen SCN. You can capture the data migration with that SCN, and then you can so start the replicate with that SCN. So you have an option start replicate at SCN or after SCN, you have some option. So with that option only, you have to start the replicate. For now, I'm going to directly start replicate, but in real time, you have to start with SCN as well. Okay. So my replicate is running, and this is my replication looks like. Okay, this is my report file, parameter file, and checkpoint file, and this is ggsa.log file, and this is how the trail file it has initiated. Okay, so currently there is no data because I haven't replicated. So let's go and insert some data in Oracle side. I have so let me check the record count in accounts table. So I should have this many records. The same record should have in the Postgres because yesterday we have migrated, right? So let's connect to pSQL /c database name set What is my schema name? Set such underscore path equal to. This is my schema name. Let's check the count of this accounts table. It is same because yesterday we have migrated, all records has been migrated to Postgres. Now I'm going to insert one record. Probably what I can try to do. I have already prepared the insert statement. So I'm going to insert some values into this accounts table. It looks like this is already exist. Let me do one more thing. I have changed the values because the same record is already present. Because of the constraints, it's not able to allow. Okay, even this is there. Let me change some value. Yeah, so let me insert again. Change all.
Maybe this is related to some constraint.
Yeah, constraint.
The foreign key constraint, right? Yeah.
The record which I'm going to insert, it's already
parent key not found. That means some child record here. Yeah.
Okay, so maybe we can take the other table, which does not have any. Probably this is a child table. First, we are trying to insert in the child table. Let me capture the other table. Let me check the table called notes. Okay, this is having how many records? It has 2 records. Let me check here. It is also having 2 records. Maybe based on the definition, we'll try to insert some data. So I'm just giving some date. I think I have to give something like this. Okay, and okay, it is created by, not created date. So created by, I can just give something. So let's give commit. So let's start from. So I've inserted a record. So let's go and see whether our extract and pump has captured those data. Yes, that's if you check. So it has captured a record which we have inserted just now. So it is from nodes table only. And you can also check the stats of your pump. Pump has picked those records or not. Okay, maybe we can directly check in the replication side how it looks like. Still, it has not captured properly. It is running properly. Your extract has been captured, but by your pump is not captured those changes. Okay, this is the issue actually. Oh, this is a remote write. It has already pushed the trail files. And
I think maybe the cross version having some issue in heterogeneous.
No, it should replicate actually, because from lower to higher it should work, but somehow the extract process is not able to capture it. Let me check.
Maybe the pump was not added properly because it's not reading that extract file, right?
Yeah,
It should read that extract file, because if you see the RBI, it's still showing as 0.
yeah, because RBI is showing 0 because of yeah, maybe previously if it is 0 means that is fine, but now we have done some insert, it has to capture.
No, here if you see your GGR Oracle GG21 underscore home did that. So that location is not the actual location, right?
No, this is the remote location actually.
Okay.
Because in the pump we have mentioned the replication, because here it is transferring the pumps actually. But why it is not reading this, I'm not sure. Let me check.
Can we view the in detail for the pump? Then it will show which extract is reading and which GG21 home. That is different, right? Is this GG21 home?
This is
different.
This is our.
That is Postgres, right? GG21 home is Postgres.
Yeah, that is Postgres one. Let me see. Okay. What is home for? Yeah, correct. This is something. Okay, let me do one thing. Let me stop this pump. It will take some time for do some recovery. So let it do. Probably while adding the pump, maybe I have added wrongly or not sure. Let's verify one more time. Maybe I will try to add one more time this. Okay, so let me stop the forcefully. So let me delete this and add it again. Okay, so let's first verify view param. So we are telling to copy as remote trial into this location, something like this, right? So while adding, we have to point out the local trail file and the remote trail file. So let me see. Yeah, that is the issue actually. I have added the wrong location because let me add it again, the pump. So this is my local trail files, right? So local trail file should be pointing to this. And my remote trail file is okay. And this is my remote trail file. Now, let me see if pump can able to. Now it is having the correct path. Yeah, now RBA is moving. I think this is perfect, but we'll see what happens in the replication side, because the RBA is moving and we can verify the data. Okay, so the data has been replicated. So now we have this. Yeah, so that is the issue, because while adding the local trail file, I have pointed out to the Postgres pump trail file. That is the only issue one, because while adding, so I have added wrongly. Okay, that is the reason. Now, if you see, it is replicating, right? So your data has been replicated. So this is the one which we have inserted in Oracle. It has replicated in the target. Okay, so this is how you can set up a replication. Probably I will provide a lab manual, whatever the steps which we do. So you can also try to practice. Okay, so just don't confuse while I have just do yesterday. I have done like replace all. That is the reason it has replaced all the binary homes to the Postgres side. That is the issue. Okay, so while you practice, just verify one or two times what path we are giving in the trail file, especially these trail files. Okay. So any questions on this Golden Gate?
When we are trying to do a resync, I mean, from, let's say, if there is any data mismatch between Oracle and Postgres, so in that case, we have to do this Ora2 PG again, and while starting the replicate, we need to use with the SCN. Is that what we have to do?
Yeah, when you do the initial setup, like first you have a schema which has to be migrated. First you do the structure migration.
Okay.
And if structure is everything looks good, then if you're trying to go with so data migration and you want a continuous replication from Oracle to Postgres, that time what we have to do, you can just capture the current SCN number in Oracle. For example, so you can capture the current SCN number, and when you do with Oracle PG, so I have structured both the sites. Now I want to go with the data migration. So in Oracle PG, you can just specify this SCN number. Okay, while you will be running for migration, like data migration, you just use this SCN number, and you can start the data migration using this SCN number. Now, before that, anyhow, you are going to start the extract and pump, right?
Yeah.
Before you start the actual data migration, you have to start the extract and pump. Then you use the Oracle PG or whatever tools which you are using. With the help of SCN, you can start the data replication. So at the replicate side, you have to start with this SCN so that it will understand, it will read the trail files from this SCN only.
Yeah, okay.
Yeah, so that is how you have to do. But if you think like you want a continuous replication, then you want to do a cutover, that time you can do this. If you are doing a POC, okay, then at that time, like you can do multiple times data replication. You can also try to test this SCN numbers and all the things.
Okay, yeah, sure.
Yeah,
one question with reference to this. Golden Gate also requires some memory settings. What I noticed is in Oracle, stream spool size memory parameter is
yes,
very
from
critical.
90s.
For Postgres, what is that?
Postgres side, you don't need any parameter actually. So you have to give the cache efficient size, right, which we have. That is, it will also use the OS memory as well. So that is the only parameter. Anyhow, that will be default we are going to enable. So we don't need any special parameters. Only parameter that we need is in Postgres side. Okay, so wall level. So wall level we need, and we also need to allow the local connections. Like we have the listener, right? Listener address, we have to give the start. We have to allow only these two parameters is mandatory. Okay, apart from this, we don't need any special parameters. All parameters which is effective cache size. This is the one important. Okay, so this is anyhow we are going to give. Okay, so when we configure the cluster, we are going to give this parameter. This is the one which we need. Okay, but from Oracle side, we know that important parameters is the golden. Sorry, SQL plus. So golden gate replication, you have to make it true, and as usual, the shade pool, okay, and stream pool which you have to enable. So from 19C, definitely that parameter you have to enable, that memory parameter. Okay, so and you should have the sufficient memory because it will use 2 GB. Actually, each process will use the 2 GB of memory. So at least maximum that you also need to have sufficient memory as well in both the sides. Okay, so yeah, that only those parameters are very important. Apart from this, in Postgres side, there is no special parameters that we need to consider.
Okay, thank you.
Okay, let me share another slide. Just give me a second. I'm going to share one more slide regarding LIDB. Yeah, Raj, you can continue.
Hey, thank you, Suresh. Okay. So actually, this is the LIDB basic introduction, guys. Okay. So LIDB is nothing but it's like advanced flavor of Postgres SQL. Okay. It is coming from Google. Okay, so we already discussed about this particular slide related to what exactly the Postgres SQL. Okay, so it's an open source. It is having the rich functionality. It's already proven with a lot of the critical application already migrated into the Postgres SQL. Then it is having like very strong community. So these things it's already proven things. All those things. Okay, so then what about like LIDB? Next slide. Can you change, Suresh? Okay, so actually what is the LIDB here is like LIDB is coming from Google side. Okay, this is a cloud, Google cloud database. Okay, so LIDB, what they did is from Google is like they took the source code. Okay, they took the source code from PostgreSQL community. So then they added, okay, so they added like very rich functionalities into that. Okay, so it is, we can say like LIDB is nothing but like the PostgreSQL flavor from the Google side. Okay, so what exactly LIDB, like how it is differ from like other PostgreSQL flavor is, okay, so LIDB is like behaving same like, okay, it is same like the enterprise DB, how it is behaving in other RDBMS system. Suppose if you compare like MS SQL Server, if you compare it with Oracle, okay, if you compare with DB2 or Informax, okay, so some of the like the same the rich functionalities are not available with the PostgreSQL community version. So the Google team, okay, Google team, what they did is they took the source code from a community version of the PostgreSQL. On top of that, they added, okay, so they added like a cloud native architecture of the Google. Okay, so and with help of the like engineering team, okay, with help of the engineering team from the Google side, so they added like rich functionalities, okay, and if you feel like if you are using the LIDB, you will feel like the database is similar to like what are the legacy database systems like Oracle, PostgreSQL, Oracle, MS SQL, or some other databases, okay. So, but those same kind of features are not directly available from the PostgreSQL. So those features are like coming with LIDB. And also the main important thing is from Google side. Okay, so the Google is enabled AML capabilities on top of the LIDB. So it means the community, the source code from the PostgreSQL plus cloud native architecture from like Google side. Okay, and AI capabilities. Okay, this is, we can call it as the bundle from a Google side. We can call it as like LIDB for PostgreSQL. Okay, so yeah, next slide. Suresh. Okay, so maybe we can maybe we can think like suppose if you are already working in the PostgreSQL for many years, it may be on-prem or like PostgreSQL on top of clouds. So like maybe you may have the doubt like why not PostgreSQL? Why we need to pick the LIDB? Okay, so LIDB having the like highly scalable advantage. Okay, and the performance. Okay, the performance of the LIDB is maybe if we compare with the traditional PostgreSQL, it is 4 times faster than traditional any flavor of the like or any version of the PostgreSQL. Okay, and it is related to transaction workload. Suppose if you are like maybe dealing with analytical workload, so the performance is 100 times faster than any traditional PostgreSQL flavor. Okay, and it is highly available system. So why? Because we are having in LIDB we have the like similar kind of cluster flexibilities. So in Oracle RAC, what we are having, right? So the similar kind of flexibilities we can get it with the help of the LIDB. So it is like within the region between the availability zones, or maybe if you are choosing the like a different region with different high availability setup, like how much money you want to spend. Okay, so it is highly scalable and it is highly available. Okay, so the performance also, it is like maybe compared to like as I said, okay, the traditional workload, it is 4 times faster. Okay, and for analytical workload it is like 100 times faster. It is already proven, okay, so by the Google side. Okay, and also the maintenance or the management of the LIDB compared to any RDBMS systems. So, I mean, like especially we're discussing here about the PostgreSQL, right? Okay, so the maintenance of the PostgreSQL is like we need to discuss something about the vacuuming. Okay, so that is a high level of maintenance activity, right? So here in LIDB, we can have like adaptive vacuum. So the adaptive vacuum is nothing but like with help of the AI capabilities. Okay, so what are the maintenance activity we are doing as a TBA from our side? Okay, so it is automatically managed and it is automatically like taken care by internal AI capability functionalities. Okay, we don't need to worry much about the maintenance activity or maybe dynamic parameters changes. Okay, so all those things is taken care by uh, 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 like uh, uh, a functionality from Google side. Okay, so that is a very a big advantage from LIDB. So we no need to tune the parameters manually. Okay, it is automatically pick. Okay, it is automatically pick, and also it is using, okay, it is using the smart storage. Okay, it is using the smart storage from the Google side. Okay, and also the storage. Okay, the storage which is using inside the LIDBs. So it is we are using like YouTube, and we are using Google, and we are using like remaining flavor or maybe remaining products from Google side, right? Okay, so maybe if you consider the YouTube, like so every day or maybe every minute, like a huge amount of data, like huge amount of videos are coming into the Google side, right? Okay, if you think big on this side, okay, so how much storage it is required, okay, for storing that that particular thing, and also you don't feel like any performance issue, or you don't feel any like maybe due to some network issue from your side, sometimes you will feel like some slowness. Okay, but from Google side, hardly you will get any like downtime or anything. Okay, so it means the smart storage it is using for almost all products from the Google. Okay, even LIDB also like deploy on top of the smart storage from the Google side. It is like highly scalable. Okay, and also suppose if you consider, okay, if you consider like maybe for using Cloud SQL, PostgreSQL on top of any cloud. Okay, so if you want to do, or if you want to like improve or if you want to like add some instance, so you need to taking care about the storage as well. Okay, but in case of LIDB, so it is deployed on top of the smart storage. Whenever if you insert, or whenever if you add any new instance into the PostgreSQL, LIDB PostgreSQL, okay, so it is in a minute, or maybe we can say it is in like seconds. Okay, so how it is like, so the storage is common for entire your cluster. Okay, so whenever if we are adding read pool instances, or whenever if we are in columnar instances, okay, so LIDB is automatically will pick the like storage from allocated storage for particular instance. Okay, this is like very fast, we can say. And also as I said, okay, the maintenance, okay, and the dynamic performance related parameter tuning, everything is like automated by AML capabilities. Okay, so artificial intelligence and machine learning already integrated with LIDB. And recently Gen AI, okay, so Gemini AI also integrated with LIDB. So like almost every product from the Google is like, right, every product from Google is like integrated with the Gemini. Okay, so yeah, so next slide, Suresh. Okay, so maybe we can maybe discuss something about why LIDB. Okay, so first thing is it is integrated with AML capabilities. That is the one big advantage, like as a DBA. So we don't see like AML capabilities related to maintenance activities, tuning parameters, and other stuff. Okay, so all those things as a DBA we need to take care, but in LIDB, like all these parameters, tunings, and all the maintenance activities almost. Okay, so with help of AI integration, it is taken care by Google itself. I mean, like the managed instance itself. Okay. So, and one more advantage is disaggregation of like compute and storage. It means it is going to offload. Okay. So in LIDB, so the IO is offloaded from like DB engine to storage engine. Okay. So then the latency, okay, the latency between the or maybe we can say the IO between the storage and engine and the database engine is like almost like it means like it is offloaded directly from database engine to storage engine. So directly it is picking. Okay, directly it is picking from the storage engine. Okay. So then, as I said, like LIDB using the intelligent storage. Okay, so then if you are adding or if you are removing, okay, so we don't need to spend more time on that. Okay, so LIDB like scale up, and it may be like horizontal and like vertical scaling. It is very quick and it is very fast. Okay, so next thing is like the vacuuming. So as I said, like the vacuuming is the like highest level of we can say maintenance activity in the any community or post version of the PostgreSQL. But here we are using the adaptive vacuuming. So with this help with help of the AML capabilities. So the vacuuming, okay, the way the vacuuming is performing in LIDB is like very quick, and we don't need to spend much time on this particular topic. Okay, so then auto memory and auto memory scaling management. Okay, you can see here in the right side diagram. Okay, the traditional PostgreSQL having suppose I have like 100 GB of memory. In traditional PostgreSQL, like if you allocate like 50 GB memory to system memory, and 50 GB memory can allocate to the buffer cache. So then, they like system memory is like only use the cap wise like 50 GB, and buffer cache memory you can use 50 GB of like cap. Okay, but that is maybe the traditional or maybe normal PostgreSQL. But in LIDB, so the memory scaling is like we can say like it is automatic. Okay, so suppose whenever there is a need, okay, suppose if you see here in the right side diagram, system memory is like 75 GB, and the buffer cache is like 25 GB. So based on the demand, it is automatically picked from another system memory area, and it is allocated to buffer cache. Okay, so it is, we can consider like LIDB autopilot. Okay, so this capability, like it is automatically, okay, so directly or maybe indirectly, it is going to like improve the performance of your database. Okay, why? Because when is needed, when is the memory is needed, it is automatically allocated from like the free memory, which is like allocated for some other resources. Okay, so this is the beauty of like LIDB. So maybe if we like dig into internals, okay, it will take like a lot of time. Okay, so yeah, so this is about LIDB. Any other slide? I think Suresh, no, right?
Yeah, no other slides.
Yeah, that's it. Yeah.
Yeah, any other questions?
Yeah, in terms of this interview, so what kind of questions can we expect with respect to Postgres?
Mostly
we will share the document.
Yeah, we'll share the interview questions actually.
Okay.
So mostly related to replication and vacuuming, you have to concentrate. So that is the main part, and remaining everything is normal, like some of the tuning tips and how, in terms of Oracle, okay, you can just compare what are the functionalities which will not support and what is the workaround.
Okay.
Based on that only all these questions will be asked.
Okay.
We'll share the few of the top questions which we experienced. Okay, so we'll share the document.
Okay, and also with respect to this resume, so any tips and in terms of what we can.
Yeah, even that also we will provide. So we have already few points which we can add in the resume as well.
Okay, okay. And also going forward, can we have a when we have a group in WhatsApp where we can share our ideas? It's not that you have to respond all the time, but at least for sharing purpose.
Yeah, that is for sure, no problem. Whatever questions or anything you have, you can just put in the chat. I mean, in the WhatsApp. So whenever we are available, we can reply on that.
Yeah, sure. Yeah, thank you.
Yeah, I think thanks. I think it's been I think almost more than 2 months.
Yeah.
It's a good journey, and all the best for your future as well.
Yeah. Thank you, Suresh. Thank you, Sriraj. I mean, I think Postgres is completely new to me because my entire experience is into Oracle. So, but thing is, this is a very good learning experience for me. But only thing is, we need to see learning is different, and while we are working, that's a different scenario, right? If we are working on Postgres, we will be learning so many things and we'll be exploring so many options. But so this is an entirely different experience, and I thank you for your time because you have provided what you could in the best of your knowledge, and thank you for that.
Yeah, thank you, Sukesh, and thank you, Sriraj. I really appreciate it. I think I got some knowledge from these classes. But again, once we are into some projects for all these migrations, maybe we will learn much faster. It's more of practice than anything else.
Yes, correct. So you have to keep practice, then only you will face some different issues and you will get some ideas and all. Yeah. Okay. Just studying theory.
And the videos will be available for some time, right?
Yeah, it will be available until 1 year. No worries. So.
Okay.
Yeah. Yeah, Raj, do you want to add anything?
Yeah, thank you, team. Like maybe it's been a long journey from last 2 months. Okay, so hope you guys are enjoyed the classes. Okay, so sorry I wasn't driving. Okay, so all the best for your PostgreSQL journey. Okay, and PostgreSQL DBA journey. It's hottest technology, and focus more on migration related stuff. Okay, so yeah, please reach out to us if you have any doubts or if you have anything required from our side. Okay, so we are here to support you every time. So we are not considering you guys are already completed my course. Okay, so no need to connect with these people, not like that. Okay, so you guys can reach out to us anytime. Okay, so we are happy to help you guys. Okay, So hope, yeah, so you guys enjoyed our classes. Okay, so thank you so much. Okay, so I will meet again. Okay, so whenever if is needed. Yeah.
Okay, thank you. Thank you, Sriraj.
Thank you so
Suresh.
much. Thank you.
Yeah, thank you. Thanks.